Welcome to What That Means with Camille. In this series, Camille asks top technical experts to explain, in plain English, commonly used terms in their field. Here is Camille Morhart.
Hi, and welcome to today's episode of InTechnology podcast, What That Means, Energy Efficiency in the Cloud, where we'll get into power consumption in the data center with Intel fellow Lily Looi. Lily Looi is Chief Power Architect of Intel's Xeon product line. We were going to talk about power consumption in the data center being servers, basically. And servers exist on-premise within companies. They exist in cloud environments, which means essentially server farms that sit outside of companies. And then they exist in hyperscaler environments, these sort of massive server farms housing tons of information. Just to set the context, can you describe basically what kind of information even goes into a data center, just at a very, very high level? Because I want to know that before we get to how much power consumption it even uses in the world.
If you think of the internet, it's all run off of different data centers. So if you're shopping, you would be logging into a data center and picking out your product. Another data center would be if you're renting out a cloud instance and you want to use it like your own server to process your company's records or whatever. You can rent out a cloud instance from a data center. It's really pretty broad in terms of what goes in and out of that, but really everything comes in through the network and it gets processed and stored off somewhere. So there's a lot of data flowing back and forth and a lot of data being processed.
Some data is processed at the endpoint or my PC or on my mobile phone, but there's also a lot of data that's being processed actually inside the data center.
If you talk to Siri, that's actually processed at the data center.
What are the numbers that we tend to agree on as a range for the amount that data centers use?
The number is about 4%. So 4% of the global electricity is being used by data centers today. And that's up from 1% from maybe 5 years ago.
How is that power being used? Is it in processing or is it in like cooling?
If you look at a data center, it's got a big building. They have to cool it, air conditioning. That is about a third of the data center's power. Another third of the power comes from, for the many servers that are in that data center, the CPU and the cooling of the CPU is another third of the power. And then the final third is for the remainder of the platforms.
It seems like the amount of data centers processing that's occurred over the last, you said, I don't know, 5 years or something, it's grown to 4% for power consumption. I imagine a lot more than 4% increase in the amount of workloads being processed in the cloud.
Oh, definitely. Pandemic just accelerated that. In terms of not just data being processed and people doing online shopping and online YouTube and searches, but also in terms of the amount of machine learning and AI that's being done. Been improving, but not at the same rate.
Not at the same rate as the performance, you mean?
Right. But just in terms of the amount of work a server can do, it's grown a lot.
What has been the drive to actually reduce the consumption of energy?
For a data center standpoint, reduced electricity means you can put more servers into that same data center. The geographic footprint matters. And of course, electricity, you have to pay for it. And at these rates, it's significant, the amount of electricity. And then finally, electricity that you're burning, if you're using any kind of carbon to generate the electricity, which is still adding to the carbon footprint, and sometimes you need to pay a carbon offset. And of course, from the, you want to save the planet. So from a good for the planet standpoint, less electricity is good.
You didn't mention software, but that maybe plays a part in controlling all of those thirds as well.
So yeah, software is what is running on the data center, and inefficient software will burn more power. Good software will be more efficient. And then software for sustainability or for reducing carbon footprint can actually help the problem.
Take us through each one of these. I mean, take us through the CPU and the cooling of the CPU. Like, what is being done on that level to help address that or optimize power consumption?
In a data center, each CPU has lots and lots of cores, and it has, memory interface and IO interface and lots of cache. So it's very complex. First, you want it to be running most efficiently while it's in full operation. And for that, there's circuit techniques and there's process techniques. But a lot of time, pieces of it are not being run at full speed. or maybe not even being used. For example, you may not be using every single core all the time. One of the very common ways to save power is turn it off if you're not using it. Just like in your house, if you're not using your lights in a room, you turn off the light. So that is one power saving method when you're not using it. Another power saving method is if you're using it lightly, turn it down. Instead of running at full frequency, maybe run at a lower frequency. Of course, you have to be careful not to just turn things off and turn things down to the point where it takes a while to turn it back on. So it has to be weighed against whatever kind of performance impact there could be. And you want the intelligence to know when it's okay to turn it off and when it's not. So if like you just left your room for a minute to go grab something and come back, you may want to leave the light on.
Aren't servers like more efficient though, the more of their capacity is running? Does the efficiency increase the more they're being utilized, if that makes sense?
The thing with the data center is you need to plan for the worst case. So like during the Christmas holiday season, or in China, the big shopping seasons, you're going to see a spike. You want to make sure everybody has good performance. So you'll be running 100% there and it'll be fully utilized. But let's say it's the off season, there's less shopping. Wouldn't need to necessarily run everything 100%. But you'd need to have your data center set up so that you can handle that peak. And in the off seasons, maybe when there's not so much shopping going on, or maybe at night, you could even turn some of them off or to a lower power state. And the ones that are up, maybe have the things that aren't running full speed, have them off or turned down.
You said another third is storage, networks, other kinds of processing. How are those being addressed from a power consumption perspective?
So there's a lot of what I call platform features where they work together to turn off like a link if it's not being used, or turn it down or half width or lower speed, something like that.
And then cooling was another third.
There's two pieces of cooling. One is the cooling of the CPU. That gets lumped into that third. And there are different types of cooling. And it's like you could use bigger, more efficient fans that would cool at a lower power. Or liquid cooling is starting to come out, or even, the most extreme of immersion cooling. These are very efficient cooling methods for the CPU. And then cooling at the data center level, that would be air conditioning. And that would be having more efficient airflow in the room or energy efficient air conditioning. I have seen data centers where the airflow in the room is actually directed so that the cool air blows out through a vent.
Well, a lot of the large data centers are located in physical geographic locations that have inexpensive renewable energy.
You're still using the same amount of electricity, but it's green electricity. For example, somewhere with like a lot of sun and then have solar. Even on that front, there's locating in a place where you can have green energy. It's still the same amount of electricity, but it's not the same carbon that you're putting in the air. Let's say it's solar. And then getting back to the topic of software orchestrating the data center and making it more efficient. If software knows the time of day, then it will know that, the data centers in this time zone have the most sun right now, so I'll schedule more work over there.
So with all of the AI that data centers are now processing, are you using AI in optimizing power consumption for them?
Oh, sure. One of the best examples is as you get ready to start using these servers that we've built out, there's a lot of different knobs and buttons that you can set to exactly optimize for particular workload or usage. One way you could tune and optimize your server is you could do a bunch of extensive analysis with these different knobs and try to find the best settings. But another way is to have AI do that for you. That is one of the techniques that we use, where AI will run some experiments and see what settings have the most impact and continue tuning a server that way. So that's one usage.
Do you know of any kind of common misconceptions in this space?
The data center and the electricity that uses is largely out of sight, out of mind. I mean, you can see your laptop, you can see your phone. You can't see the data center. You just know you're logging into the internet and doing something, and it's somewhere far away. I think most people don't think about how much processing power is actually in these data centers. I keep going back to the Siri example because it looks like your phone's doing all the work, but really it's also going to the data center and doing some processing there.
What is the biggest driver right now? I would guess AI. What is the biggest driver of growth in the data center now?
AI is a big one, but in terms of usages like cloud, people using cloud to manage their business is big.
Because just having companies migrate what they're doing from like on-prem to cloud, you're just shifting where that workload's running. But when you're actually generating, I guess, new transactions and new processing in the cloud that wasn't there before, like online shopping, that's where you're getting the growth.
I mean, it's going to grow. The amount of data that's coming in is growing. I mean, with the self-driving car example, that data is growing. The amount of training that's needed, that's growing. So it will grow. I don't think we want to stop the trend of data that's coming in because it's improving quality of life and giving us more advanced usages than we ever thought possible. So I don't think we want to stop that. We have been increasing data center capabilities and compute capabilities. And you look gen over gen, the amount of improvement in processing power has been on a steady pace of growth. We don't want to change that. We just want to make sure that as we're growing the capabilities and the performance, that we are at the same time looking at making it energy efficient. And it's not just about performance, but it's performance at a specific wattage. At least at Intel, we're baking that into how we're developing our products, looking at both power and performance and at typical utilizations.
Would AI be done differently than some other kind of workload?
There's a fine line between software and hardware, and there are certainly accelerators that you can use that do a specific operation better than general purpose software would. And so in that case, adding an accelerator and putting in a software interface so that you can run, that's one method of being more efficient for a very specific function that you need to do.
How do you start to frame this problem? I mean, if you're looking at optimizing performance per watt, essentially, for your career across servers that do everything all over the world, I mean, all kinds of different workloads, and you don't necessarily know what workloads they're going to run any given server, but you have a lot of examples of things that they do end up running. Like, how do you even approach this problem?
Well, that is one of the big challenges because there could be hundreds or thousands of different things that people could run. And the best we can do is run lots of different workloads as part of testing and qualifying our product. But when we want to design, we pick 5 to 6 workloads that are very representative, and we center around that, and we use those as a base.
Are you in the role of just at all cost, I'm optimizing for power, and then there's a colleague who's like, at all cost, I'm optimizing for performance, and then you guys have to sort of hash it out? Or are you both sort of charged with optimizing across the board?
Well, I mean, the easiest way to save power is just turn it off. That's the lowest power. But the performance is not too great when the computer's off. So I do have to look at both performance and power, but I'm looking more at the efficiency, and I'm looking more at typical usages as opposed to going 1,000 miles per hour off in this direction and trying to hit the best performance. I'm trying to have more of that balanced look at it. Now, my performance colleagues, they do optimize the 1,000 miles per hour. They're also very, very conscious of the power because at the end of the day, if you can't give enough power to a system, then you can't get that performance. So the performance guys, they're very aware of power as well.
What's your guiding principle as you go through this in your job?
It's kind of a boiling the ocean challenge. So how do we rein this into something that's actionable? One of the things I'm doing is trying to focus on what we call the golden 5. It's the top measurements and benchmarks that we use to characterize energy efficiency. And it's somewhat representative of different usages. So we use that as the basis for anytime we want to push a new feature, make it more efficient, make this circuit block do something better, or have the capability of gating off little pieces of itself that aren't being used at the moment. Everything eventually needs to roll up into these golden 5. How is it helping these golden 5?
And you look at how to architect even a data center as well then, as you're looking at within a CPU, but I mean, those are going into data centers. So you're looking obviously at the structuring of them all together.
At the data center level, there's much more you can do. We talked earlier about what if your data center it's nighttime and it's not heavily used because you don't have your global orchestration in place yet. You could actually turn some of the servers into very low powers. That's one thing you could do that are unprovisioned, and then you can bring them back up as need gets greater. That's one thing. The other thing is, as all these servers are running in the data center, you can look at what's happening in each server with telemetry. And from that telemetry, you can see which ones are busier, which ones are less busy, which ones are running this kind of workload or that kind of workload. You can use orchestration software to send the next job to a server that is maybe medium utilized and you want to use up the rest of the utilization, as opposed to waking up a sleeping server. So that at the data center, that's the type of optimization you can use.
Like, what would you say is the hardest part of your job?
Well, data center has gone a long time with performance being the focus. And it's only been in the last few years where it's gotten a lot of attention, where we passed the 1% global electricity mark. We always had some constraints, like you only get so much power per socket or so much power per data center or per rack or per server. We've always had those constraints, but it's only been more recently, like past the 1% mark, where it really mattered how much we were burning, even in the less than 100% utilization points.
So fame and glory.
Well, I mean, I drive a Prius. I love going hiking in the great outdoors. I don't want to see all the rivers dammed up, and I certainly don't like the wildfires that we're now getting every year in Oregon, which seems to be a thing now. Anything we can do to reduce the carbon footprint, reduce electricity, of course, is good for the planet. But on top of that, using less electricity and being more efficient so that the data centers can run more efficiently and be more economical, that's of course important too.
How did you get involved in power optimization?
When the electricity and the carbon footprint of data center became a big deal, it was about the same time that things like the annual forest fires of Oregon started up. And so when I heard there was need for more people looking at power and energy efficiency, I jumped at the opportunity.
Very cool. I literally, no pun intended. Thank you, Lily. Lily Looi is fellow at Intel and in charge of, with the title possibly chief, power consumption for Xeon, which is Intel's data center line. Thank you for speaking with me today.
Thank you.
Never miss an episode of What That Means with Camille by following us here on YouTube, or search for InTechnology wherever you get your podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.